rolling already. Okay, so how are we running our lesson? Okay, I'm trying out something new. Okay, I'm trying to use SLS in my lesson. Okay, so that when it comes to home-based learning, right, everything that you see over here, it will seamlessly tie into what you're doing for home-based learning. Okay, so I will be assigning this entire package, okay, to everyone. So home-based learning itself, right, okay, I will tell you what is the tab to do. So this is from your point of view, okay. This is for the entire chapter 1. There's 1.1, 1.2, and 1.3. So you can go to different sections, okay, and each section got different activities. So I will be telling you very clearly when it comes to home-based learning, which section and what activity I need you to do. All these instructions I will be putting up onto Google Classroom once all of you know your email addresses and you can be on board onto Google Classroom. So for next week one, I will tell you before our home-based learning lesson. Okay, so the maths lesson before, I will tell you what to do. Okay, so that you know what to expect. Right? So now 1.1, our chapter, we will be learning about prime numbers. How many of you are familiar with prime numbers? Just a show of hands. Okay, that's good. Right? But then we still have to touch upon prime numbers. Okay, for those that don't know, those that don't know, never mind. Okay, so prime numbers in this section, these are the things that you will be learning. What prime and composite numbers are, and what is index notation. Okay, so from your point of view, you will actually press enter. This is the first thing that I want us to do. Okay, but then because we are not having our laptops now, so I'll just do it verbally. Okay, so let's recall what we did in primary school first. Okay, can you tell me 3 examples? Give me 3 examples. You can just shout it out. Okay, 3 examples of whole numbers. 4. Okay. Let me just erase this. Okay, we have 4. 5. 4, 5. What else? 6. Okay. And what are not whole numbers? Give me an example. 1.5, right here, then. 1 and 1, 12. 1 and 1, 12. 1 and 1 over 12, is it? And then? 1.9. 1.9. You always at 1 point something, oh? Okay, good. Okay, I think we are all clear about what are whole numbers and what are not whole numbers. Whole numbers are numbers starting from 1, 0. Okay, we are starting from 0, right? Sometimes I forget. I'm so sorry. Let me take out my book. Okay, yes, starting from 0. Okay, starting from 0. Okay, so whole numbers start from 0, 1, 2, 3, and so on. Okay, then non-examples. Okay, your fraction, your decimals, those are not whole numbers. Okay, good, there we go. Right? Then let's go on even numbers. Okay, what are some examples of even numbers? 2, 4, 6, 8. Okay. Is 0 an even number? Yes. Okay, 0 is an even number. Okay. I'll explain later in case some of you don't know. What about not even numbers? 1, 3, 5. 1 and a half there? 1 and a half?
1 and a half is even number.
1 and a half is an even number. Oh, okay. So we are a bit confused of 1 and a half. Even or odd? Okay, or maybe none.
Fraction.
Okay. So for even numbers, I think we are clear about what are even numbers. How do we define even numbers? Yes. Numbers that what? 0 or 2? Oh, 0, 2, 4, 6, 8. Okay, can I have a clearer definition rather than listing all the numbers? Can be divisible by 2. Very good. Okay. Huh? 0 is even. Okay. So even numbers are numbers that can be divisible by 2, right? Okay. So let me just write it down. Grab my markers. Yes.
It's just that some are repetitive numbers
Xavier. Okay, so Xavier says that actually every number can be divided by 2. Just that there are some numbers that are actually, that have remaining numbers at the back. Or that's what we call remainders now, right? Okay, so actually everything we press calculator we can divide by 2, right? It's just that whether there's a remainder or not. But for even numbers, would there be remainders? No, right? So to be more clear about this definition, even numbers can be divided by 2 and has no remainder. Right? Okay. Going back to the idea of 0, 0 is even number because when I take 0, I divide it by 2, do I get a remainder? No. Okay. So therefore, 0 is an even number. Okay. Next part asks for non-examples of even numbers. That means that they are not even numbers. Okay. Not even numbers does not necessarily mean that they have to be odd. Okay. It can be any number so long as it's not even. Okay, so we have clearly 1, 3, 5 and so on. Just now when I asked 1.5, is it even or none? So how many of you say even? Okay, who says odd? Alright, okay, then who says none of it? Okay, just now I think Carmen you say that it's odd, is it? Okay, why do you say it's odd?
Like 1.5, we change the decimal to 1.5.
Okay.
1.5, the last number of 5 is 1.
Okay, so she decides it based on the last number, okay, which is a similar definition to just now. One of you said that the last number, if it's 0, 2, 4, 6, 8, then it must be an even number. So because it's odd, then she concludes that it's an odd number. Then,
Add a 0 at the back.
if I can always add a 0 on the back, and then it seems like it could be an even number, right? Because 1.5 is the same as 1.50, isn't it? Okay, then how? Okay, then some of you say none of it, right? Sorry, just now who said none? Oh yes, Erqi, you said none, right? So why is it none? Oh, because you don't know, okay? Then anybody else has a reason over why it's not even or odd? Yes. Okay. Okay, so she says that if I have 0, it seems like it's an even number, don't have 0 is an odd number. Okay, I think this is an interesting question to actually ask. I think after teaching Set 1 so many years, it's the first time that I have to address this. Okay, even and odd numbers, we are only looking at whole numbers. Okay, even and odd numbers need to be whole numbers in the first place. Okay, so maybe to tighten this definition for even numbers, they must be whole numbers. Okay, so it must be whole numbers that can be divided by 2 and has no remainder. Alright, is 1.5 a whole number in the first place? It isn't. So therefore we cannot classify 1.5 as even or odd. Okay, you understand? Okay, so therefore 1.5 is actually none of it. Right? Now, I realized I forgot to tell you how to write notebook. Okay, if you write really good, I hope that you have good note-taking skills. I want you to write down, okay, the chapter that we're looking at, chapter 1, which is primes, highest common factor, and lowest common multiple. Okay, let me enlarge this. Can you all see it? Is it too small? Okay, let me just write it here then. We're looking at chapter 1, primes, HCF, and LCF. Currently, we are looking at 1.1 prime numbers. Okay, this shall be in your title. In your content page, you just write down the chapter in vocabulary. So that we have an organized notebook. Those that don't have a notebook today, I want you to just write it on a foolscap paper, if you could. Okay, then once you have the notebook, I want you to just staple it inside. Okay. Any questions? Okay. So what is an important thing for you to write down? Okay, from our discussion so far. Okay, those things is okay if you don't write down. Those are for us to discuss. Okay, so you can write down. I want you to write down what is considered an even number, can be divided by 2 and has no remainder, must be whole numbers. 1, 2, 3, 4, and so on. As we progress, we may need to increase our speed in writing also. Cannot write like our primary school, old grandmother, grandfather kind of speed. Okay. The notebook is meant to serve as a consolidation of important information in class. Okay, so don't be a photocopier. Okay, to copy every single thing I write on the whiteboard. Okay, write down really what is actually important so that you learn proper note taking skills. Okay, we are not here to be photocopiers. Okay, so please think as I'm teaching and write as I'm teaching as well. Okay, shall we move on? Right, we're not going to be watching these videos since I'm here now. Okay, so why is it that we had all this discussion earlier on, okay, about whole numbers and even numbers? Okay, knowing what is even number and odd number is a way for us to actually classify our whole numbers. I want to learn how to group things, alright? If I have so many numbers, our whole number system, I can separate it up into even numbers and odd numbers. So if I can do it that way, the next question as a mathematician, what we ask is that, how do we actually go about maybe classifying in other ways? Is there something else, another system, other than doing it by even and odd? Okay, I think that within whole numbers itself, we want to think of other ways. And one of the ways is to determine based on the number of factors it has. Okay, do you remember what is a factor? What's a factor? Let's say maybe I look at the example 30. What are the factors of 30? 1 times 30. Okay, I have 2 times 15, 3 times 10, 5 times 6. Okay, so we see that 1, 2, 3, 5, 6, 10, 15, 30 are factors of 30. Okay, that's what we know about the term factor. Okay, it is a number that we can that can form a product, okay, with another number such that we get the 30. Okay. So if I want to look in the factor direction, we notice that if I have a series of numbers, let's just look at from let's say 1 to 10. Okay, from the numbers 1 to 10. Okay, I want to see which of the numbers has only maybe 2 factors or 3 factors or more. Okay, so let's see number of factors. How many factors does 1 has? 1 only, which is 1 itself, right? How many factors does 2 have? How many factors does 2 have? 2. Okay, we have 1 and 2, so there are 2 factors for 2. Okay, so I'll just write it down like that. Okay, what about 3? How many factors are there? 1 or 2? 2. Okay, we have 2 factors, right? Okay, which is 1 and 3. Maybe more income. What about 4? How many factors does 4 have? Let's think about it. I forgot to bring my ice cream sticks. Ready? Let's find another student. Okay, more class. The Rose. Rose is you, yes. Okay, how many factors does 4 have? 3. What are they? Okay, 1, 2, 4. So there are 3 factors. 1, 2, and 4. Okay, how many factors does 5 have? 2. Okay, so 1 and 5. How many factors does 6 have? 4. What are they? 1, 6, 2, 3. Okay. Then how many factors does 7 have? 1 and 7, 2. Okay, what about 8? Let's maybe get someone over here. Very quiet. Don't quite remember. Where's 8 Kim? Who's 8 Kim? Oh, okay. Sorry. Didn't get correct name. Yes. How many factors does 8 has? 4. What are they? 1, 2, 4, 8. Okay, so we have 4 factors. Okay, what about 9? How many factors does 9 has? I know this Xavier. Xavier's partner is called. Huh? Jun can you tell me how many factors does 9 have? 2. What are they? 1 and 9, you sure? 3. Okay, we got 1, 3, and 9, right? And then how many factors does 10 have? Let's say the last one at the back. 4. What's your name? Joshua. Okay, 4. So we have 4 factors for 10 and they are 1, 2, 5, and 10. Okay, so I have listed out the number of factors that all these numbers actually have. Okay, all these numbers are whole numbers. You agree? So do we observe anything over here? We observe that, okay, the numbers itself, usually it is either having 2 factors, okay, otherwise it's nothing that is 2. Okay, so mathematicians decided, okay, that they will call this kind of numbers prime numbers. Okay, so what is actually unique about prime numbers? Okay, prime numbers, they have not just 2 factors, but their factors are 1 and 2, 1 and 3, 1 and 5, 1 and 7. So they are numbers that have factors 1 and itself only. Okay? So, your question might be, what about 1? Is it a prime number? Okay, it is not a prime number. Why? Because it only has 1 factor, 1, which is the value of 1. Okay, so therefore 1 is not a prime number. Okay, so what you want to copy in your notebook, okay, I leave it up to you whether you want to copy this whole table now, or you can just write down what is the key point over here, that prime numbers have factors 1 in itself only, 1 is not a prime number. Okay, so we just now also agreed that 0 is a whole number, and since we are trying to classify numbers in your whole number system, the next question is 0 a prime number? No. Why is it not a prime number then? 0 cannot be divided by? Cannot be divided by any number, are you sure? 0 can divide by any number, right? Just that cannot be divided by 0 only. You can take 0 divided by 1, 0 divided by 2. Just that the value ends up to be 0 lah. Okay? So 0 actually can be divided by many numbers. Alright? It's not just 2 numbers. So therefore 0 is not a prime number. Okay? Right, so we can do this check for all the numbers, okay, they are whole. Right? Your question in your mind might be wondering why we want to do this kind of thing. Okay, isn't even and odd numbers enough already? Okay, so only when I was in universities then I understood the beauty of prime numbers. Okay, so I don't want you to wait until university I share with you now. Okay, something that my lecturer told me about prime numbers. Okay, prime numbers are very important and very beautiful because there is no pattern to it. Okay, so there is no formula, okay, that I can say that I can put into the computer that will be able to generate for me, okay, that this is going to be a prime number. Okay, I cannot see that first it starts with 2, then 3, 5, 7, 9 is not a prime number. I don't see any pattern going on. Okay, and what's so important about not having a pattern? Okay, nowadays we put our money in bank, right? Okay, so I think all of us put our money in banks, okay, and we do a lot of online banking, isn't it? Right? And for online banking or anything that is online, okay, we want to make sure that it is secure. Okay, it is very close. Nobody is going to come and steal my money just because they take my phone away. Okay, or actually maybe some people steal your money because they take your phone away. Because they always send a PIN number, okay, a very unique number to your phone, okay, such that only you yourself have, and then after that you can get access to your money and all that. Okay, all these kind of things, all these coding kind of things, they are what we call encryption. And encryption, right, okay, relies on prime numbers, okay, for us to actually make sure that it is secure enough because there's no pattern going on for it. Okay, I'm just describing it in a very loose manner. If you really go up to higher levels, okay, to pursue mathematics or any of such things, okay, security sense, maybe you have a bit better picture of it. But at this juncture now, I can only describe to you in a very loose manner. Okay, so that's the importance of prime numbers. Okay, so in case you're curious, then now other than prime numbers, we have this other thing called composite numbers. Okay, composite numbers are numbers that are not prime numbers. We use the red marker. Okay. They are numbers that are not prime numbers. So therefore, looking at the list that we have over here, if I were to generate, okay, a list of example, I will see that 4, 6, 8, 9, 10, they are what we call composite numbers because their factors itself, okay, it's not just about one in itself. They have other factors as well. Okay? A question that you may have in your mind now is, since 1 and 0 is not a prime number, does it naturally mean that it is a composite number? Okay? The answer is no. Right? 1 and 0 are unique numbers. Okay? So 1 is not a composite number as well. Neither is 0. Perhaps it is because, okay, as the name suggests, okay, composite means that it is being made up of many other things. Okay, 1 isn't made up of many other things. 0 is made up of maybe too many of it. Okay, so therefore 1 and 0, they are neither prime numbers nor composite numbers. Out of prime numbers itself, what is the smallest prime number that we have? 2. Okay, 2 is the smallest prime number. How many prime numbers do you think could be even? 1. Can there be more than one even number that is going to be prime? Okay, very good, Ati. Alright, so Ati was saying that, okay, there cannot be other even numbers that could possibly be prime because other even numbers will always be divisible by 2. Then it will never be 1 in itself only. Okay, so there is only one even prime number, and that is 2. And that happens to also be the smallest prime number that exists. Okay, smallest prime and the only even prime. Because we got our Chromebooks, you will not be able to use our Chromebooks to answer it. But don't have to worry because I have source and alternative. Okay, and that is to use our pickers. Okay, so I want us to answer this first question. Can I erase this part of the board first? Okay, erase Okay, let's just do a quick check-in. of what's going on so far? Okay, I hope that you know how to use your fingers already. Anybody doesn't know? Yes, toilet. Okay, go. Oh yeah, I forgot to tell you, if I go toilet, you raise your hand, you show me the T sign, I'll let you go. Okay? And then when you come in from toilet, please stand at the door and then knock before you come in. Don't just walk in. Okay? So have you decided? Maybe pick up my phone, start scanning. Okay, which of the following is a prime number? Okay. I see that most of you seem to be getting it right. Okay. Okay, make sure your name appears. Okay. Anybody else? What about Asher, Brandon, Joan, Nadias, Lucas? Anybody? I don't think I corrected. I see so many figures with me. Okay. And anyone else? Okay, Alright. Let's see. Most of you choose 5 as the prime number. Okay. We do have people who choose 0 and A and C. Okay, so the correct answer is actually D, which is great. Just want to say out the names who actually didn't get it correct. Just in case, okay, you actually don't know how to use it. Okay, so Yushen, you didn't get it right. Okay, and then Lucas T, Lucas Ang, both of you also didn't get it right. Elena and Kyra, right? Okay, didn't get it right. So, you put your answer as C. So maybe later on, I mean, no, nothing wrong over here. I'm just telling you, maybe just now you turned the wrong way. Okay? So next time now we can try again. Next question. Which of the following number is not a prime number? Okay? Once you're ready, you can put down. Next come in. If you put wrongly, you can still raise up and then change one and I can still update it. Yeah. So long as you put down your book already, I will stop scanning. You. Is that it? Okay. Anybody else? Elena? Yourself? Okay. Okay. Let's see. Right. One person didn't get it right. Okay. Most of you give me C. So 4 is certainly not a prime number. 2 is a prime number. Okay. That's Lucas Lucas you don't answer, or is it you written wrongly? Written wrongly, okay. So never mind. Nothing wrong, okay. We all here to learn. Okay. Next question. What is the smallest prime number? Okay. So the answer is actually B, which most of you got correct. Okay, I do have one person who gave C 4. Okay, Elena, you gave me 4. You check. Can someone help Elena? Okay, maybe the boys at the front. Okay, tell her how to show the B. Nothing to be laughing about. Okay, we just help each other out. Elena, you got it? Okay, you clear now? Very well. Okay, good. Alright. Next question, second last one. Identify all the prime numbers between 40 and 50. Okay. So this one you might need to think a bit. Alright, so how to think? Maybe you try using your calculator. Okay, take the numbers that you see. Okay, try to press. Yes. Okay. Right, you can use your calculator, do a bit of pair work. Alright. Okay, stop. Okay, so yeah, number of you give me A, B. Okay, I think all of us know that D confirm not answer. Why is D not answer? Because of the 46. We already know that even number cannot be other than 2. Okay, then after that the answer is actually C. Okay, 41, 43, and 47. Alright, why? For A, which of the number clearly is not a prime number? 49, right? Because we know 7 times 7, 49. Okay? And then after that, this one, okay, it's not very easy. Actually, it is 51 that's not a prime number. Because 51 can be divided by 3. Yeah, it can be divided by 3. Yeah, and then also 51 is above this. Okay, 51 is more than 40 and 50. Yeah, so therefore, this one is not answer. Okay, any other questions? Right, last one. Okay, what is the largest prime number less than 100? Yes, you can change. So long as you raise it up. Okay. Right. Okay. Don't worry about getting it wrong. Just give it a try. Okay. Okay. Any more? Okay. So, most of you give me 97. Okay. And some of you give me 91 and 99. Okay, 99 cannot be like, if you know, right, 99 can divide by 9. Huh? And we can divide by 11. So, the correct answer is 97. Okay. So, 97 is a prime number. Okay, it's largest prime number as well. So, we start counting from behind. After before 100 is 99, which cannot be 98, cannot be since it's even. So it's between 91 and 97. 91 itself, I think, can be divided by 13, right? 7. Can be divided by 7. Okay. So I hope that with this activity, it makes us more certain about what is considered a prime number. Okay. Our next lesson, which is next week, okay, we're going to learn how do we identify prime number. Okay, because we saw that it is actually quite challenging to find prime numbers that are so big. Okay, it is not that easy. Some of you start pressing your calculator as well. I wonder what